Okay, so today we're going to be talking about one of my favorite lessons, and this is talking about solving systems of equations. So whenever you're solving a system of equation, there's 3 different ways I'll teach you how to solve it. Some work better than others at certain instances, but all are useful at certain times. So the most basic way of solving these by graphing is that you will just graph the lines and see where they meet. So the place where these 2 lines meet, the intersection point, is going to be your solution. That's the answer to these types of problems. So it's going to be a coordinate. All right, so I know this looks a little crazy. That's something that you're not really used to, this y equals and then the bracket. That's okay. It's just like 2 different equations. That's one way to write it. So let's graph the first one, y equals negative x plus 3. So you'll go up to positive 3, let me zoom in, and then go down 1 over 1 a few times. Okay, so it'll look something like this. Try that again. Not great, but there it is. Okay, and the other one, you have a point at negative 2. So this is, let's do this one in green. So negative 2, and you're going to go up 3 over 2. Even though my line isn't perfect, you can see where they're going to cross. Okay, so this coordinate would be 2, 1. And that would be your answer for this system of equations. All right, let's do the next one. Looks like the top one, or both of them, we're going to have to convert to either find the intercepts or convert it to slope-intercept form, and I'll just convert it. So we have 2x minus 2y equals 4. So subtract 2x from both sides. We'll have negative 2y equals negative 2x plus 4. Divide by negative 2. Y will equal, that would be a positive x, and then a negative 2. Okay, let's graph it. So we go down to negative 2, and then up 1 over 1. Man, my lines are really bad today. Okay, the next one, we're gonna just have to add x to get this in slope-intercept form. So we have y equals x plus 6. Okay, so plus 6, that'll be up 1 over 1 again. All right, what do you notice about these 2 lines? Well, they're parallel. So if they're parallel, where are they going to intersect? They're not, right? They're parallel, never going to intersect. So if they're parallel lines, there's going to be no solution, ever. So your answer would be no solution. All right, let's talk about the pros and cons. The pro, it's a good visual, right? You can see clearly where they connect, and it makes sense what the answer is. It's a point where they connect. These are easy to use. It's easy if you have a graphing calculator. It's really quick. It's easy/quick with graphing calculator. Because you just stick it in there and it'll tell you exactly where they intersect, and you don't really have to do a whole lot. So like on your ACT, this is what I would definitely suggest using because you'll have access to a graphing calculator. On this unit test, you won't have access because I want to know that you can do the work and graph it or solve it the other way. So, but otherwise, if you're taking an ACT or another test, you would be able to do it. Con, let's say just lack of graph paper. So lack of graph paper. And then another con would be sloppy graphs. I mean, look at mine. Sloppy graphs. Part of that lack of graph paper, if your answer was a big number, maybe your graph didn't go up to 300 and your point was 300, 203 or something like that. So sometimes that can be a pain. And then it takes time sometimes, right? To make your graph, if you didn't have a graph already made for you, can take time. Okay, so graphing is my least favorite way, unless I have a calculator to solve these. So the next one I'm going to talk about is substitution. And this one works great at certain times. Sometimes it's not as easy to use, but it just depends on the situation. So how you use substitution is you solve for one variable in one of the equations, and then substitute the expression into the other equation and solve, then input the answer back into one of the original equations and solve for the other variable. Okay, let's just start doing it. I think it'll make more sense once we start. Okay, and I did change this problem a little bit, so if your problem on your notes is different, go ahead and change it. So this one, y is already by itself on the second equation. So what we're going to do is we're going to take all of this and input it to this y right there. So let's do that. So we still have the 2x. Let me see. So we still have 2x minus 2. But now we're going to have to do 2 times all of that we highlighted. So it'd be 2x plus 2 equals 4. Go ahead and use the distributive property. Make sure you realize you're distributing that negative 2. So that'd be negative 4x minus 4 equals 4. Combine your like terms. Negative 2x minus 4 equals 4. Add 4 to both sides. Negative 2x equals 8. So x will equal negative 4. Good, we have one of the pieces for our answer. So now what we're going to do is we're going to take that. Let's see what this red highlight looks like. So we're going to take this. We have x equals negative 4. And we're going to plug it in to one of the equations, whichever one is going to be easier for us to solve for y. In this case, I think it'll be the second one. So I'm going to plug it in for that x right there. So it would be y equals 2 times negative 4 plus 2. So that would be negative 8 plus 2. So y equals negative 6. Okay, so what does your answer look like for these types of problems? Remember, it's a coordinate. So you're going to have parentheses because it's an ordered pair. You're going to have your x value first, of course. So it'll be negative 4, negative 6 is your answer. Okay, let's do another one. Again, I changed this problem because it was kind of yuck. So let's work this one out first. Are any of our variables by themselves? No. Does any of them look easy to get by themselves? Well, it looks like we could get this y by itself pretty easy. So let's just subtract 2x from both sides. So on the second equation, we'd have y equals negative 2x plus 6. Sweet, that wasn't too bad. All right, so we're going to take all of this. And whenever you substitute it in, it has to be into the other equation. You can't substitute it into the same equation. It won't work. So go ahead and substitute that in for this y right here. And let's go ahead and start this. So we would have 2x minus 2y equal, minus 2 parentheses, because we're substituting that in, negative 2x plus 6 equals 9. All right, let's solve it by distributing. We would have positive 4x minus 12 equals 9. Combine like terms. So we have 6x minus 12 equals 9. Uh-oh, are we going to have a fraction? Looks like it. But that's okay. Plus 12 plus 12. And that would give you 21 equals 6x. Okay, so divide by 6, and so you have x equals 21/6. You can reduce that divide them both by 3, and you would get x equals 7/2. Or if you wanted to write 3.5, that were, or let's say 3.5. I'll use a decimal, so 3.5. So we have a fraction or a decimal, that's okay. But now we have to plug that back in to one of the equations. So I'm actually going to leave it as the improper. I think it'll make it easier. And which one seems like the easiest one to solve for? Well, for me, it would be the y equals one. So this one, let's plug it in for that x right there. So I could have plugged it in for this one, and you would have still got the same answer, but we would have had to do one extra step. If you want to do that, you can, or you can use the one that you changed. It doesn't matter. Or you could use the top one. It doesn't matter. Any of those 3 equations would have worked. Okay, so we have starting thing. So we have y equals -2 times 7/2 plus 6. Oh, sweet, those cancel. And it will be y equals -7 plus 6. So y equals -1. So your answer for this is the ordered pair. Let's say 7/2. We'll just keep the fraction. 7/2, comma, -1. And if you wanted to check it on Desmos and graph it, you can. Graph the 2 lines where they intersect is the answer. Okay, last one of these. So, oh, look at me. I already gave you the problem with it already by itself, so ready to substitute. We don't have to move anything. So we're going to have 2x plus 7. Also, if your homework doesn't have, or if your notes don't have these problems, go ahead and write them down. So we're plugging that in for that y right there. So I would have 4x plus 2 times 2x plus 7 equals 8. Distribute. 4x plus 14 equals 8. Combine like terms. Plus, oh, sorry, doing the wrong thing. Subtract 14 from both sides. 8x equals, what would that be? -6. Hey, we're gonna have some more fractions, that's okay. So divide by 8, divide by 8. X equals -3/4. Okay, so we're gonna plug this in, this -3/4. Which one looks like the easiest? The second one, I think. And for that x, so let's do that. We have y equals 2 times -3/4 plus 7. So that becomes -3/2, which is like -1 1/2, plus 7. So that would give you 5 1/2 for your y. So your coordinate would be -3/4, comma, 5 1/2. Okay, let's talk about the pros and cons. Well, the pros, if you noticed, using this way, you can get fraction / decimal answers, which whenever we were solving by graphing, you could only get whole number answers. Okay, another pro would be sometimes if the y, or let's say variable, if variable is isolated already, like the last one had the y already by itself, this can be faster. Cons is if it's difficult to isolate the variable, it might not be the best way. So can be difficult to isolate variable. What else? Sometimes it can get messy. You have to be organized. So must be organized. That's kind of all these problems actually, because they're kind of long. So must be organized. I'm sure there's some other cons, but let's go ahead and move on. So elimination. So this sounds difficult, but I'll just tell you what it is, then we'll do it. So first you need to line up the terms with the same variables, constants, and the equal sign. So all of them, the x's need to be under the x's, y's, equal sign, constant. First, see if any cancel. So they cancel by adding the two equations together. If they don't cancel, then multiply one or both equations by a number to make them cancel. Solve for one variable, then plug in the number to the other equation and solve for the last variable. So I'm going to skip to letter B first. So letter B, I really should have wrote it below. Let's just do this. I'm just going to move this one over. So it's 3x plus 4y equals 12. Are they lined up? Yes. X over x, y's over y's, and the numbers and the equal signs are all lined up. If I were to add them together, the x's, would they cancel? No. 3x plus 2x is 5x. 4x and 2x, or 4y and 2y is 6y. So those don't cancel. But what I could do is I could multiply one of them, and I'm going to pick the bottom one, by a number. Try to think of the number that would be beneficial. Hopefully you thought -2. So I'm going to rewrite that top one, doing nothing to it. So 3x plus 4y equals 12. And then after I multiply that -2 to all three terms, don't forget to do all three terms. That's a really common mistake. So that would be -4x minus 4y equals -10. Okay, now, so we're ready to add these equations. Remember, you add them. So 3x plus -4x would be -x. The y's cancel, good, that's what we wanted. And then 12 plus -10 would be -2. Divide by -1, so x equals 2. Sweet, that wasn't too bad. We already solved for x. Now we just need to plug x in for one of the other ones to solve for y. Doesn't matter which one. I'm going to plug it in for this one right here. Because that y, it's only a 2y. So let's go ahead and do this. So we'll have 2 times 2 plus 2y equals 5. 4 plus 2y equals 5. We're going to get a fraction, that's okay. So 2y equals, +1. Divide by 2. Y is 1/2. So we have our coordinate. The coordinate is 2, 1/2. That's your answer. But as you can see, that one wasn't too bad. It canceled nicely. We did have to multiply it. That's okay. Sometimes you don't even have to multiply it. It's kind of great. Okay, let's do this one. Okay, so looks like we're close to being able to cancel. Go back to letter A. We're close to being able to cancel, but we're not quite there. Well, what do we need to do? Well, looks like to me we need to, oh, I see a problem. Does anybody else see the problem? Look right here. Your x's and your y's are not lined up. So let's get those lined up. So 2x minus 2y equals 4, and then I'm going to switch those other ones. So it'll be -x plus y equals 6. All right, now it looks like we need to multiply the bottom one by 2. So we have 2x minus 2y equals 4. So that, and then the bottom would be -2x plus 2y equals 12. Let's go ahead and add them together. Oh, looky here, the x's cancel and the y's cancel. So you would have 0 equals 16. Is that, since everything's canceled, it's going to be, or the variables have both canceled, it's going to be a special solution. So is this true? Does 0 equal 16? No, it does not. So there is no solution, which means AKA these lines are parallel. All right, just a few more to go. So let's do this one. Looks like nothing can cancel. We're gonna have to multiply both of them. Sorry, this is so blurry. Do we want the x's or the y's to cancel? To me, it'd be, let's do x's because they're a little bit smaller numbers. So you're looking for the least common multiple of 2 and 3. Well, that'd be 6. So we're gonna have to multiply this by something to get it to either 6 or -6 because we need one of them to be negative. Let's do this one. So we're gonna have to multiply that by -3. And the other one, we're gonna have to multiply it by +2. So that'll get them to cancel. So the top one, we would have -6x minus 21y equals -12. The bottom one would be +6x plus 10y equals -10. All right, let's go ahead and add them together. Oops. So we would have x's cancel, y's, you have -11y equals, that's -22. Divide both sides by -11, so your y equals +2. Sweet. Whole number answer. So now let's plug that in. Doesn't matter which one. I'm gonna go ahead and just plug it into the top one. Doesn't matter. So I'm gonna have 2x plus 7 times 2 equals 4. 2x plus 14 equals 4. Subtract, that would be -10. Divide by 2, so x equals -5. So it looks like we have our answer. The answer would be -5, 2. So as you can see, some of these problems, they work out nicely, and you don't have to show all the work that you have to on substitution. Okay, on this one, let's do this one. Looks like stuff's already ready to cancel. We don't need to multiply anything, so let's just add them together. Well, -3x and 3x, that's 0. This is going to be 0, right? Y and -y. And this is also going to be 0. So when 0 equals 0, that's true. So what would this be? Remember your special solutions. This would be infinite solutions. So what does that even mean? Well, let me show you something. So I'm going to take this, I'm going to put these problems in, or these equations in slope-intercept form just to show you what that meant. You don't have to do this on your homework by any means. So if I had the -3x plus y equals -5. So I would add 3x to both sides. And I have y equals 3x minus 5. Okay, now let's do the other one. So let's do 3x minus y equals 5. So I'm going to subtract 3x. So you would have -y equals -3x plus 5. Divide everything by -1. So y equals positive 3x minus 5. What do you notice? Well, hopefully you notice, hey, these are the exact same lines. So of course, if you graphed a line, so we have a coordinate plane here, and you graph this line, let's see, it looks something like this-ish. That's the blue one. The red one's going to be the exact same on top of that same line. So since they're the same line, they're going to have infinite solutions. Every point on this line is going to be a solution, and there's an infinite amount of points on that line. So that's why it's infinite solutions. Okay, let's talk about the pros and cons of elimination. So sometimes it can be easy if they cancel right away. sometimes it can be less work if it's quicker, so it can be less work. You can get fractions, so you can get possible to get fractions and decimals. I'll just put fractions. All right, cons. Can take longer if you have to multiply both, so it can take longer sometimes. Otherwise, this is one of I don't have a whole lot of cons for this one. This is usually my favorite one. So let me just show you something on these ones. Like on this first one, another way, since these variables are pretty, like the y and the x are almost by themselves, if I were just to see this problem, I probably would have used elimination on this one. Or sorry, substitution, where I would have got the y by itself and then substituted it in. Other ones, so like if I were solving these up here, like this one right here, I would have tried to do elimination, the last one. You just kind of have to know what the problem is and like which is the fastest. If the directions in the homework or the test say to solve it a certain way, of course solve it that way, but if it doesn't tell you, do whichever way your brain sees as the fastest and easiest way for you. All right, thanks for watching. I hope you have a great day.